Good, all right. So yeah, as was mentioned, I sort of have a distant relationship with Alan Turing. So this year is the 70th anniversary of his untimely death at the age of 41. He's considered the father of AI and of computing, really. And in 1950, he wrote this paper where he asked, can machines think? He introduces what is now known as the Turing test. Now, as was pointed out, I went to university at Sussex. This was my tutor. He was the man who built the first transistorised computer ever in the whole world. And his tutor, in turn, was Alan Turing. So that makes me a grand tutee of Alan Turing. And entirely by coincidence, I later went to work in Manchester in the department, in Alan Turing's old department, and worked on the 5th computer in the line of computers that Turing, you could say, initiated. He worked on 1, 2, and 3 up to his death. I should say his death was unfortunate because he was gay, and in 1950 that was illegal, and he got found guilty and chemically castrated, which sent him into depression and killed. So he killed himself. So it's a great loss to science, to mathematics, computer science, to artificial intelligence. I moved to Amsterdam. I've been in Amsterdam most of my life now, and I moved to Amsterdam to work on a new programming language, and that new programming language became the basis for Python. So that's Guido van Rossum in the middle there, and me on the edge. If you don't recognize, this was one of our departmental meetings. And as was mentioned, I was purely, by luck, the first user of the open internet in Europe, because the CWI set up the first open internet connection in Europe. And by the way, I'm counting the UK as part of Europe in this. So the guy who'd set it up, I knew it was coming. He knocked on my door. He said, "The internet's up." So I said, "Oh, great." And so I logged into a computer in New York just to try it out. And that was the moment the first user of the internet used in Europe used the internet. I got involved with the World Wide Web right from the beginning. I organized workshops at the first web conference in 1994 at CERN. And through that, Tim Berners-Lee, that's him there with me, we're singing a song together, invited me to be involved with the setting up of W3C, the World Wide Web Consortium. And as a result, I've helped design HTML, CSS, XHTML, XForms, RDFa, and a bunch of other web technologies. This talk that I'm about to give is actually the part of a course that I give at a summer school at Oxford University every year, which includes an introduction to AI. It's not the principal subject of the summer school, but it's part of it. So let's get on with the talk. So there are currently 2 ways of doing AI. You either teach the computer what you want it to know, or you let it learn for itself. So I'd like to just go treat both of those, and so we'll start off with teaching or encoding our own knowledge. So to take an example, let's take noughts and crosses, or if you're from the Americas, you might know it as tic-tac-toe. Now I imagine that everybody here can play that perfectly. So what we want to do is we want to teach the computer how to play it, and there are 2 ways you can do it, principally. You can either give it rules, or you can give it states. So let's take rules first. What you do is you give the rules about how you play. So for instance, the number 1 rule in noughts and crosses is, if you're about to win, make that move and win. The second most important is, if you're about to lose, block it so that you can still continue playing. And after that, well, there are some rules about how you choose what next move to make. But anyway, you get the idea. And this is actually rather hard. It's rather hard to come up with the rules about how you play, to sort of get it out of your brain and into terms of rules. But it's one of the ways of doing it. The other way is to encode states, and it's rather easier, and it's in a way more objective. And that's because what you do is you take all the possible boards, and although there are more than 20,000 possible combinations of X naught in space on a 3x3 board, there are actually 765 unique possible combinations of those, legal combinations, as it were. So you only have to take those 765. The reason is that you've got a lot of symmetries and rotations and so on. So these 4 are actually all the same, so you don't have to code them separately. So, and these are similarly also identical board states. So what you do is you take each of these boards one by one, and you record how you would respond to that. And so then you've encoded your knowledge of how you would play it, but in terms of states. And so then when the computer has to play the game, then it just looks up the current state and it says, oh, well, okay, you play that move, so I'm going to make that as well. And so that's how you've taught it how to play noughts and crosses. So just as a matter of interest, for those of you who know the game and play it, which is the first move that you make? You can either take the center, one of the corners, or one of the edges. So who takes the center when you play it? Okay, who takes a corner? Okay, and who takes an edge? Nobody takes an edge. Okay, interesting. All right, we'll talk about that shortly again. Now, the other way is learning. So I've talked about 2 ways of encoding your knowledge, and now how to let the computer learn. So again, we take those 765 boards, and we link from each board what the possible follow-up moves are. So when you've got the starting board, the empty one, then there are only 3 possible responses you can give to that, either an edge, a center, or a corner, as we've just spoken. And similarly, if you've got a center piece, then there are only 2 possible responses to that, and so on. So you link them all up, and you give each link a weight of 0. And then you play the computer against itself. So, and how does it play against itself? It takes a random move again and again, X and a naught each time, and then you come to a point where it's either a draw or one of them is 1. If it's a draw, you do nothing, but if one of them is 1, then you add 1 to all the links that it took, and you subtract 1 from all the links that the losing side took. And then you just play that thousands and thousands, tens of thousands of times. Actually, it's surprising actually how few times you have to make it play. I mean, when I wrote this program, I thought it would have to be millions, but in fact, it's only tens of thousands of times before you get a computer that plays perfect noughts and crosses. So you play it many, many times, and then when you use the program, then when the computer looks at the current state of the board, and it takes the link with the highest weight, because that's the one that has won the most times. And so that's how you teach the computer how to play noughts and crosses. Now, if we want to compare these 2 modes of doing AI, then the encoding one, you can only encode, of course, what you know. You can... which may encode bias or mistakes. Your knowledge may not actually be perfect. So that's a risk. But you can work out why the computer makes a particular move or does a particular thing, because you've encoded that as rules, and so you can sort of either write the program so that it tells you why it made that decision, or you can look it up. The learning method, well, again, it's only as good as the training material you give it. This can also encode hidden bias, because there may be bias in the training material. In general, it can't explain why it makes a particular move or a particular decision. But the nice thing about it is that it can discover new things that maybe you didn't know yourself. But note well, in both cases, it's not true intelligence. It's just learning, but it's not intelligence. So let me just take a few of those points. So bias. So in 1970, only 6% of musicians in American orchestras were women. And then around that time, they introduced blind auditions, so that if somebody auditioned for the orchestra, you couldn't see who they were, what color they were, what gender they were. And since then, the number of women in orchestras has increased incredibly. Boston is at a third, and New York is at 50%. Now, you can't imagine in 1970 that they wanted bad orchestras. They want the best orchestra possible. So clearly there was some bias, and clearly it wasn't deliberate, but nonetheless there was bias. Another example is that sentencing software for criminals in America was trained on existing sentencing, so that it's still biased because black people get thrown in prison more often than white people, and the software still does that itself. Here's an example of not being able to explain. I actually got this image. It asked me, are these the same people? For some reason, it thinks these are two faces. This is Google Images, Google Photos. But you can't ask, why do you think that's a face? Because it just does. Why can't AI explain itself? Well, in fact, humans can't explain themselves either. Why is it an Italian wooden serving dish and not a wooden serving Italian dish in English? Why is it a lovely little bird and not a little lovely bird? Why is it a silly old fool and not an old silly fool? Well, that's because in English, there's an order to how we use adjectives. Opinion, size, age, shape, color, origin, material, purpose. We all, as English speakers, have that rule in our heads, native English speakers, but we can't say what that rule is unless we've actually studied it. So there's no intelligence in AI as we know it yet. And an interesting thing is that saying all corners are the same, as I did at the beginning in noughts and crosses, is actually encoding some knowledge. And so what I did was, I realized it was encoding knowledge and not letting the computer learn it. So in fact, my learning program already encoded some knowledge about noughts and crosses. So I rewrote it without that knowledge. And the interesting thing is the two programs play differently. And for instance, the first move, the one with the encoded knowledge, takes a corner first, because actually a corner is a better first move than a center. The corner is an attacking move, whereas a center is a defensive move. And so you're just slightly more likely to win if you start with a corner than if you start with a center. So that's an example of bias, that if you programmed it to take the first move in the center, you're actually biased against what is actually objectively a better move. So the two programs play differently, but the one that does the learning will never learn that the corners are the same. It plays differently because it doesn't know the corners are the same, and so it doesn't see that if you added those corners up, you'd actually have a better chance than if you'd taken the center position. So why do we think intelligent programs that we currently are using are intelligent? And I would claim that it's because of pareidolia, that we have this thing as humans of interpreting everything in terms of ourselves. So for instance, and this is the classic pareidolia, we all see faces here, but there are no faces. You have to admit there are no faces there, but we see faces, and that's pareidolia at work. Here's another example. This is a film that went around the internet showing swans feeding fish, which was sort of like amazing. These swans are feeding their fish. Isn't that nice? Because the swans can get to the food and the fish can't. The swans are not feeding the fish. That's how people have interpreted it. The thing is, swans can't eat dry food, so they take the dry food and they wet it. And in wetting it, they drop some of the food, and the fish then know about that, and so they catch it. The swans aren't doing anything for the fish there. They're doing it for themselves. They're wetting the food so they can eat it. So that's our pareidolia, again, working, interpreting it in the way that we would see it feeding the fish, but that's not what's happening. Another example is Joseph Weizenbaum, who wrote a program that imitated a psychotherapist. It was purely textual, picking up on keywords and giving responses. But when he gave it to his departmental secretary to try out, she asked him to leave the room so that she could talk personally to it. But there was no personal there. It was just purely automatic, and she was using her pareidolia to think that it was actually intelligent. And this has happened recently at AI with Lambda, somebody who worked with one of the programs imagined that the AI chat program was sentient because he asked it, are you sentient? And it said yes. And so he assumed that it was sentient and said, we must never switch it off again. They sacked him, by the way. So we have this tendency to interpret intelligent programs, non-intelligent programs as if they were intelligent. They're only machine learning, but we think that they're intelligent. And then we get shocked when they make stupid mistakes. This is a mathematics question out of a school exam. It's meant to show that you are intelligent and you know what's really going. So it says an orchestra of 120 players takes 40 minutes to play Beethoven's Fifth. How long will it take 60 players? Well, ChatGPT says it would take twice as long. So the Turing test, which I mentioned earlier by Alan Turing, proposed that we would be able to tell when computers were intelligent by putting you at the end of a teletype and typing questions to, and you didn't know whether it was a person or a computer, and then asking questions to try and determine if you've got a computer or a human at the other end. So in that paper that I mentioned, this was an example of what Turing proposed as a session. In the first line of the sonnet, which reads, "Shall I compare thee to a summer's day? Would not a spring day do as well or better?" Reply, "It wouldn't scan." Well, how about a winter's day? That would scan all right. Yes, but nobody wants to be compared to a winter's day. So I thought, I'm going to try this out on ChatGPT. Now, ChatGPT is terribly verbose, so I'm not going to read this out to you because we don't have the rest of the day for this talk, but I'll just point out some of the terrible things that it did. So I asked it exactly that question. It didn't mention scanning, but it said that summer is traditionally seen as the season of love and passion. Not true. Spring. That's why this question is asked. Spring is the season of love and passion. That's why it might be a better comparison. So ChatGPT didn't do very well there. The slides will be online, so if you want to read this whole conversation this evening, you can be. So I said, well, you forgot to mention that it wouldn't scan. And then you sort of get this big apology. Oh, sorry, yes, you're right. Oh, sorry for the oversight. And then long blab, blab, blab. It really likes the sound of its own voice. And then it gets it completely wrong about how the stress works in the process. So that's an example of it seeming intelligent, but in fact, the real intelligence that you're looking for is not there at all. It's just giving you an answer that it thinks might match. I asked ChatGPT to make a bio of me, and it got it completely long, saying that I've got all sorts of honorary doctorates and stuff, which I haven't. But if you want to give me one, please do. But none of this was true. So it's not intelligent, and the nice word, the nice phrase that has come up is stochastic parrot, because that's really what it's doing. It's learning all these texts and then sort of creating new texts based on the text that it's read. So there was this paper written on the dangers of stochastic parrots, which pointed out all the dangers of modern so-called AI programs. And as mentioned, well, financial costs, but inscrutability, not being able to see why it makes it, biases, the inability of the models to actually understand the world, and the possibility of deceiving people. Anyway, the people who wrote this program this paper got fired by Google for writing it, because I think that Google didn't like people criticizing their AI. But anyway, on the basis of this, I thought I'd like to poke fun at ChatGPT, and I said, somebody said to me, ChatGPT is like autocomplete on, and then didn't finish the sentence. What do you think he was going to say? Well, so again, blah, 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 but it gives me two possible solutions. ChatGPT is like autocomplete on steroids, or ChatGPT is like autocomplete on a whole other level. As you will see, I said any other possibilities? As you can see, ChatGPT has a very high opinion of itself. On steroids, on a whole different scale, on a massive scale, much broader range, generate full sentences, smarter and more intuitive. It really loves itself. So I said, well, how about on crack? And again, blah, 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 blah. And it said, but it's important to use discretion and sensitivity when using language that references drug use. Well, I bet you can guess what I said then. Your very first answer was on steroids. Steroids are a drug. And then you go, oops, you're absolutely right. Sorry about that. And then a whole blah, blah, blah about why you shouldn't use drug references. So then I asked, don't you think I might be making fun of you? And then it sort of owns up. I don't have emotions. And so worry is not something that it can do. So I said, well, how about irony? And again, it owns up. I don't have the ability to detect irony in the same way that humans do, which is honesty, but I think that this is an example of the lack of intelligence. If you can't spot irony, then you're definitely not very intelligent. So I want to briefly go through how ChatGPT works, greatly simplified, but at least it'll give you a feel for it. So what I did, and again I took another small example, I took the first chapter of James Joyce's Ulysses, just because I had it available actually. It contains about 1,100 sentences, 7,000 words, 40,000 plus characters. But of those characters, only about 3,500, about 9% are the letter E, but only 24 are an X and 33 a J. So these are the first few lines of Ulysses. So what I did with that, I generated random texts from that, only using the statistical likelihood of a character appearing. So you've got about the same percentage of E's in this and the same percentage of X's and J's and so on. So as you can see, it's complete nonsense. It is unrecognizably English, I would say, even though this has the same statistical property of English in terms of the frequency of letters. So, but there's another statistical property, that is that if you've got a letter, it can only be followed by a smaller number of letters. For instance, a Q is only ever followed by a U, and a Z, well, at least in this training set, is only followed by E, I, O, Y, and Z. So what I do is I select a character at random, and then the next character randomly from the letters that may follow it. So it already begins to look a little bit more sensible. It's not quite as much rubbish, but it's still rubbish. You can still see an occasional word. But okay, I've now created this using 2 letters, but what if I do 3 letters? Well, all of a sudden it starts getting even more English-like. And if I do 4 letters, well, even more English-like. By 5 and 6, we've only got English words, more or less. It's very interesting to see how, with very little information, you can actually create at least English words just using statistical properties. Okay, but I've done this only with characters, but then, of course, you can do it with words. Here, I just take words at random. Again, it doesn't make much sense, but if I take pairs of words or triples of words, it gets more and more like English, and you actually get things that are sort of understandable. By the time I get to quadruples, well, because of the small learning set, I actually only get lines out of Ulysses, but that's only because I've got a very small learning set. So ChatGPT is really just this process, but then on a huger scale, because it's read the whole of the internet and it uses other statistical techniques for meaning. But what it does, it just generates text related to what you have typed. It doesn't do any understanding, no real understanding. It's just parroting stuff at you. And this is why we get such crazy images like this, because it's the same process. It's sort of piecing bits of photos together. And you very often see that it doesn't know the difference between an ankle and a wrist, and which is why you sometimes get a foot at the end of an arm rather than a hand, and vice versa. So, generalized intelligence. So what will happen if we do finally get real intelligence, when there really is an I in AI? And when will it happen, and what are the consequences? So there's something very interesting. When my grandfather was born, which 1880, he really only had 2 technologies in his life that you would call in any way modern, trains and photographies. You might want to include flushing toilets, but that's really the limit of the technologies that he had at his disposal. But in his longish life of 90 plus years, he saw an amazing number of changes. The list is absolutely huge. Electricity, telephone, lifts, central heating, cars, films, radio, television, recorded sound, flight, space travel. The number of things that changed in his lifetime was enormous. And we're still seeing enormous numbers of changes. Mobile telephones, GPS, cheap computers, self-driving cars, all this stuff is happening now in our lives. And the question is, are paradigm shifts, which is what these all are, they change your thinking about a particular thing in our life, money or travel or whatever, are paradigm shifts happening faster and faster? And the answer is yes. And this is a very interesting bit of study that Kurzweil did. He asked a large number of disciplines, I think 15 disciplines, representatives from a large number of disciplines, to identify when the paradigm shifts happened in their discipline. And we're talking over huge periods. We're talking over 10 to the 11 years here, because some of these technologies are like metallurgy, where the paradigm shifts happened over thousands of years, moving from iron to steel and so on. But then he graphed them. He graphed all these, comparing the time it took between, this is the time between events, and this is time before the present. And what you can see is there's clearly a straight line there, a worryingly straight line, because this is 100 years, and it's heading down to 10 and then 1 year in the very near future. So this means that paradigm shifts are happening faster and faster, exponentially faster. So that it means that if they used to happen every 100 years, then at a given point they start happening at 50 years, then 25 years, and so on, so that you end up then with 1 year and then a half year and so on down to days. So if I just calculate this just to give you an idea, if at some point they're happening every 100 years, then after 100 years they're happening every 50 years, after 150 years they're happening every 25 years, and so on down to when you get to 200 years, they're happening daily. So how is this possible? Is this possible? Should we expect this to stop? Well, the funny thing is we've seen this thing happen before. In the 60s, we already knew that humanity was doubling the amount of information that it had, the amount of knowledge, every 15 years. This is a graph produced in the 60s, predicting that we were going to run out of paper in order to record our knowledge that we were producing. And everybody thought in the 60s, well, this is going to have to stop soon because we won't have enough paper. But then the internet happened and allowed our increase in knowledge to carry on. In fact, faster, even faster than we can see here. So in the nearest future, apparently, we're going to have paradigm shifts that will be happening daily. How might that be possible? Well, one of the proposals is that that's the moment that computers actually become smarter than us, and that computers start doing the thinking, the design of paradigm shifts rather than us. So if that's the case, and that's an if there, but if that's the case, then for the first time on this planet, there will be things smarter than us. And of course, it will only be as smart of us in the beginning, but of course, assuming computers continue to get faster, then they'll be twice, 4 times, 10 times, 1,000 times, 1,000,000 times smarter than us within a lifetime. Will they be self-aware? Possibly. We don't know. We really don't know. That raises ethical questions. Will we then be able to turn them off? And let me sharpen your focus on this by saying, suppose we find a way to upload our brains into these machines, and so continue after our death, well, is it still okay to switch them off? And of course, the other question is, there's no reason why, when computers become truly intelligent, that they will be our friends. They might be neutral, we just don't know. There's no inherent reason why computers will be our friends. We have to do a lot of work to get computers not to swear, and machine learning programs not to swear or say nasty things. That will be a lot of work to make sure that they are our friends. And if you look at how we treat lesser intelligences on this earth, well, we're not very good on that. If they're useful to us, like cows, then we'll feed them and look after them for a while before killing them. If they're not useful to us, then we don't really care if they live or die. I'm not talking about us individually, I mean as a society, which is why we're getting so many extinctions currently. And if they're inconvenient to us, we will kill them at a moment's notice. Mosquito, pow, no thank you. So why would a super intelligence work differently? We have a looming AI crisis. We've known this for 100 years. This is a newspaper article from 1912 warning about an impending crisis. What have we done in 100 years? Next to nothing. We recycle our bottles. That's not going to help. But the thing is that if the computers, the intelligent computers, spot that we're the cause of that the climate crisis, and if the computers realize that the climate crisis will threaten them as well, then they're connected to the internet. They'll be able to work out how to break into computers and shut down machines just as easily as a hacker can. So we really need a plan. We should be thinking about this. We shouldn't just be going helter-skelter into the AI future without thinking of the consequences and planning for it and making sure that the bad things don't happen. Unfortunately, we're really bad at responding to crises. We respond way too slowly. See the climate crisis. So we really need to be thinking about this. So, conclusion. Humans are terrible at dealing with crises. And the question is, which will get us first, the computers or the climate, or will we actually do anything? Sorry about that.
Thank you, Steven, so much for bumming us all out on the morning. Are we doomed? Are we doomed? I don't know. But thank you so much. What a wonderful, wonderful speech. Well, and it is a cautionary tale you need to tell. Absolutely. Do we have any questions for Steven? Please. I'm sure you all have burning questions. Oh, yes. I've got the microphone here. Here you go.
Hello, Steven, again. Thank you very much for a fantastic speech. It's super inspiring, and maybe my question will be a little bit related also to data engineering aspect of Gen AI. What do you think when we will have even more data in the world, for example, in upcoming years, if the amount of data will double or triple or quadruple, will it make at some point AI more intelligent or not? Thank you.
Will it make us more intelligent?
And us as well.
The point is that the data is not holding up. So we're producing exponentially more data all the time. We really are. In fact, in some areas, more data. I mean, particularly in space, for instance, we're producing more data than we have time to do anything with. Data provides information. Information provides knowledge. Knowledge provides wisdom. Will the computers, was that your question? Will the computers become more? Well, I mean, computers are better at spotting patterns than we are. So I'm sure that machine learning will be able to extract new knowledge out of that, and hopefully we can then use that to extract new wisdom. Whether we will actually do that, the signs are at this moment not very good. The society as a whole is not very intelligent in general, and there's no signs of it getting particularly more intelligent. So I'm a little pessimistic on that front. In general, I'm an optimist, but things are a little dark at the moment.
Thank you. Yeah. So you say AI is very good at recognizing is very good at recognizing patterns.
Yeah.
How come it can't recognize zebra crossings or traffic lights? Capture, I'm referring to.
Well, okay, so I mean, there's a long answer to that, but the answer is it can, but it wants confirmation.
Right.
So when the capture, you're just giving confirmation so that it thinks that there are certain zebra crossings. So, and it just wants to know that you think the same, so that it can
It's just insecure.
It
needs reassurance.
It's learning.
Okay.
It's learning more.
We're teaching it.
Yeah.
We're feeding the machine. Any other questions? Quick question over here. There you go.
I thought it was a very convincing representation of the LLM.
Oh, sorry, it's not on. There you are now. Yeah.
Thank you. I thought it was a very convincing representation of the LLM being a stochastic statistical model.
Right.
Which was interesting. The problem I have with the singularity projections is the fact that I don't believe that you can ever get a true reasoning system with these artificial.
That we will ever what? Sorry.
Get a true reasoning system with these artificial intelligence systems. What do you think about that?
So I've no idea if we will truly get intelligence. All I know is that there's an enormous amount of money being pumped in to finding it, because the first one to get it will have a big advantage. So who knows? But on the other hand, you know, our brains are wired very much like what the programs that we're writing now. I mean, the programs we're writing, neural networks and so on, they're absolutely modeled on how our brains work. And so it's surprising we haven't yet found intelligence there, but I can imagine that somebody will find what it is, that little thing that makes the difference. So it might take 10 years, but it might happen next year. I just don't know. But I do think it's likely, quite honestly.
Yeah.
I do think it's likely.
And by intelligence, do you mean consciousness or self-awareness? Is that what you mean?
Well, I mean true intelligence, whatever that is, and I think that the Turing test doesn't work really, as we've demonstrated, because you can sort of do a Turing test to ChatGPT. But you know, an intelligence that can really recognize irony, or can see by looking at the noughts and crosses board, hey, the corners are all identical.
Okay.
That sort of stuff, that a true intelligence where insight happens.
So you say irony. So humor is one of the tests,
And
in a way.
humor as well.
Okay.
I mean, they're terrible at cracking jokes.
Yeah, but most people are.
True. But that, you know, that gives you a job, right?
Yeah, exactly. Perfect. Lovely. I think we have to move on. Thank
All
you
right,
so
thank
much,
you very
Stephen.
much.
Huge applause, please, for Steven Pemberton. Thank you so much. Thank you, Stephen. Just one, out of curiosity, I have one last go. Have you ever been asked to play Doctor Who?
Oh,
you'd be perfect.
You've no
Be
idea.
a perfect Doctor Who.
Doctor Who, Doctor Strange,
Yeah.
Mr. X.
You'd be perfect. You'd be amazing.
Well, yeah, thank you.
Perfect. Super. Thank you so much. Thank you.